It's important to note first that the speed of sound is not completely fixed, even on Earth. It depends on a wide array of factors, most importantly, whether it's passing through a gas, a liquid, or a solid. It also depends on the exact composition and temperature of those mediums. For these reasons, you could argue that even Earth has numerous speeds of sound, though not in the same way that Mars does. At 32 degrees Fahrenheit, the speed of sound through air on Earth is 1,086 feet per second. At 68 degrees Fahrenheit, however, sound travels faster, at 1,125 feet per second. It passes even faster again through water. This is because the closer molecules are together, the faster they transmit vibrations. When it comes to a planet's atmosphere, the thinner the atmosphere is, the slower sound travels through it. The denser an atmosphere is, the faster it travels, and the faster an object needs to go to break the sound barrier. Sound doesn't travel at all through the vacuum of space because there are no molecules there to vibrate. Interestingly, this is the exact opposite with the speed of light. The speed of light is fastest through the vacuum of space, and far slower when it moves through dense objects. It's stopped completely by opaque ones. In a sense, you could also say that there are multiple speeds of light too, since the speed of light is, for example, different in water. But again, this isn't quite what the latest research is saying about Mars in particular. So what is it saying? Well, data sent back by the Perseverance rover, which landed on Mars in February of 2021, featured the first audio recordings of the Martian atmosphere. The data has allowed scientists to study Mars's sonic makeup in detail, and they've come to the surprising conclusion that the Martian atmosphere affords multiple speeds of sound. Scientists in Los Alamos National Laboratory in New Mexico found that higher-pitched sounds travel faster on Mars than lower-pitched ones. This means that if a human was on Mars and had, for example, a speaker far away from them playing music, they'd hear it completely differently than if they were doing the same thing with the same equipment on Earth. They'd hear higher notes before they heard any bass, making the notes of the song seem to be all jumbled up. This all happens thanks to the sun and the fact that the Martian atmosphere is 96% carbon dioxide, compared to the 0.041% on Earth. The sun heats up the carbon dioxide molecules in Mars's atmosphere, which increases the speed of high-frequency sound waves, because the CO2 molecules remain agitated for longer when hot. This is extremely useful to know, because if we ever send humans to Mars, it could affect the way we communicate with each other. Although, of course, we'd likely all be using radio equipment regardless. But why has it taken so long for us to record the surface of Mars for the first time? The first craft to reach the planet was Mariner 4, launched from Earth by NASA way back in 1964. The following year, it performed a flyby of the red planet. But the first human-made object to land on the surface was the Soviet Union probe Mars 2 in 1971. Unfortunately, though, while it did land, it crash-landed. The Soviet Union's next attempt, Mars 3, succeeded in achieving a soft landing the same year, but failed 110 seconds later. It wasn't until 1976, then, that space agencies had their first truly successful Martian landing with NASA's Viking 1. Since then, there have been 8 others. However, only a few crafts sent to Mars have been equipped with microphones. They included NASA's Polar Lander, launched in 1999, and Phoenix, launched in 2007. Unfortunately, the former crashed into the surface and was destroyed, and the latter had its microphones switched off due to technical difficulties in order to avoid tripping a critical landing system. Neither the Spirit, Opportunity, nor Curiosity rovers had microphones built into their systems. NASA really wanted to get that sound data eventually, though, and that's why Perseverance was given 2 microphones, a descent mic for use during landing and a supercam mic. In the recordings themselves, you can't hear an awful lot, probably because there isn't a lot on Mars making noise. There's no running water, no wildlife, nothing really moving except for the wind and the rover. Subsequently, these are the only things that you'll hear in the clips, but listening to gusts of wind on Mars is still pretty amazing. It was thanks to these gusts that scientists were able to extrapolate what the speed of sound is and make the remarkable discovery about the different sound barriers the red planet's atmosphere has. We're only going to get more data like this from Perseverance as well, teaching us lots of things about Mars's atmospheric composition and wind speeds. This landmark study begs the question, what do other planets sound like? Well, while this is the first ever true recording of the Martian surface, it's shockingly not the first alien landscape ever recorded. That honor actually goes to Venus. For a while in the early days of space exploration, scientists were extremely interested in Venus, with the Soviet Union in particular sending lots of probes to study Earth's evil twin. Venera 13 and Venera 14 were identical probes with identical microphones, both launched in late 1981. This was many years after we already knew that Venus was a nightmarish, inhospitable planet, but it's still an extremely interesting celestial body. They both arrived on Venus in early 1982, a few days apart, and both transmitted audio recordings. These were the first ever true recordings of alien sounds, and just like with the noises that Perseverance had captured, we heard a lot of wind on Venus and the sounds of the landers carrying out their functions. Unfortunately, Venus's atmosphere is so dense and wildly hot that neither Venera lasted for very long. Venera 13 survived for roughly 2 hours on the surface, while Venera 14 fared even less well, enduring for under an hour. This is relatively good for Venus, but it's nothing compared to the decades that some Mars rovers have been functioning. NASA was in contact with Opportunity for 14 years. It's still bizarre to think, then, that while we've known how Venus sounds for 4 decades, it's taken until 2022 for us to finally have a listen to Mars. Naturally, the next course of action is to carry out similar tasks and experiments on other solar system worlds, to see if we hear anything differently on them. Perhaps one day we'll send a probe into the Jovian atmosphere to get measurements of Jupiter's massive storm, the Great Red Spot. Much like the Venera probes, it's not likely that such a craft would survive for very long in what would be some of the solar system's most testing conditions. But being able to listen to the red spot, even fleetingly, would still be spectacular. After that, perhaps we'd target the many moons of the solar system, and particularly those that might be more conducive to life, like Titan and Europa. What if Titan actually has life already that an audio study of its environment could reveal to us? What if we could hear the distant churning of Europa's massive oceans beneath its ice? There are plenty of major breakthroughs that research like this could contribute to in the future. Of course, we're not just collecting sounds from other planets. We've also sent plenty of sounds into space ourselves. We've sent radio messages from Earth before. Notably, a broadcast of Across the Universe by the Beatles that was sent out from Madrid towards the star Polaris in 2008. But this was a radio message. Though we can translate radio waves into sound that we can hear, radio waves are not, in fact, sound waves. They're light waves. In terms of true sound waves, we've sent 2 records, the Golden Records, into space aboard the Voyager 1 and Voyager 2 probes. These records feature an assortment of Earth sounds from many different cultures, including sounds of nature, animals, different languages, and music. They're waiting to be deciphered by an alien race that encounters either probe as they journey beyond the solar system. And finally, who could forget the Tesla Roadster launched into space as a publicity stunt in 2018. It also did its bit for sound in space research, blasting out David Bowie's Space Oddity on a loop until the car ran out of battery. The speed of sound is a delicate and constantly changing part of the universe, but on Mars, it changes more often than we suspected. And that's why Mars has 2 speeds of sound.